Hey everybody. All right, so we've talked about all of our trig identities and all the trig stuff that we've talked about, graphing and everything. Now we're going to take some of the stuff we've learned already with the trig, and we're going to go in a different direction. We're going to spin it a little bit differently. Now, before we actually get into it, there's a thing called rectangular coordinates. I think I spelled that wrong. Nope, I spelled it right. I'm good. Rectangular coordinates. Now, this is what you have been dealing with your whole life so far. Rectangular coordinates are x and y values. So you have your x, you have your y, you have your graph here, your x and y Cartesian plane. Remember that word? Hopefully you do. We have our x and our y there. And as you look at it, you graph your x value and then you graph your y value. So you go left to right and then go up and down. Now here, this, if you look at it, it makes a rectangular screen. And if you looked at before, like some books would say, okay, to graph out or show the graph on a rectangular screen or some of that sort. Now it's talking about like your x and y plane. So here it made that rectangular shape. Some people might call it square shape, but rectangular shape. So it made that shape there. This time now, we're going to do something a little bit different because we're now a trig and we have angles and all this stuff, and angles don't work on this rectangular graph. And so with that, that means we have to deal with our thing called a polar coordinate. And this is section 9-1 from your textbook. So section 9.1 or 9-1, sorry. Now, with this, instead of us now dealing with x and y, now we're dealing with angles. So our ordered pair now is going to look like this, r and theta. And with this graph now, instead of us using the xy plane, we're going to kind of use our unit circle to help us to figure out values and to graph things out. And so with that, I'm going to give you an idea of what we're talking about. Like we have our big circle here. And with it, we're going to have a couple of circles, like we call them concentric circles. And with it there's multiple circles. So it could be like 5, could be 6, could be 10. All depends on what graph they give you. And again, the graphs change, but it just depends on how many graphs they give you, and that determines how many circles you have. Now with it, you're still going to have like almost kind of like an XY thing going on. But each one of these now will have spokes coming out of it. So from the center, which is considered our pole, like almost like it's the North Pole of the globe. If you look down from the top of, if you're like going over top of the Earth and you look down on it, or like a globe, you look down on it, the North Pole is directly in the middle, and then it goes out from there, and you have your latitude and longitude lines. Kind of the same thing that's going on here. All right, so each one of these, they're going to have like at least 3. It could be like 5, could be more than that in there. But each one of these, when it comes to your R's, these circles right here are considered the R, and these parts right here are considered your angles, which if you remember back from your unit circle, each one of these had a radian angle measurement or a degree measurement. So each one of these are going to have a radian or a degree measurement for it. So with that being, before we do that, sorry, let's go ahead and do some information. So R is the distance from the pole. And again, the pole is directly in the middle. And then theta is the angle from the pole axis. Another word. So that's a new word there. Pole axis. Now, with that, go ahead and get out that big circle I just gave you guys, and we're going to look at that and we're going to work on that part. Now, with this, we have our big, wonderful, huge circle right here. And we're like, what? This is so huge. What in the world are we doing, Mr. Hall? What in the world are you doing? This is too much. Too much. It's too much. Now, with this, it is a lot going on, but it's not too much. You guys got this. Y'all can do it. All right, so with this, each one of these pretty much is your graph for your polar coordinates. So this whole thing is like your graph paper for your polar coordinates. So instead of it being like a rectangular shape, it's a circle for poles. And again, like this is like the North Pole. If you look at a globe, normally you have like these rings that go out from it. And then you have like your longitude, latitude lines and all that great stuff. That's pretty much what this is. So it's kind of the same. But on this graph, this line here is considered your polar axis. Your polar axis. Now, as we go around here, we're going to go ahead and look at the parts that go around, and we're going to give us it's going to give us our angles. Now, with these angles, again, it's what we've dealt with before, the stuff that we've seen before, but we're adding in new ones. So we're going to deal with our degrees and our radians just like we had in our unit circle. So with everything, we know it starts with 0 here. We're going to do our radians on the inside, my degrees on the outside. So we have our degree symbol here. So our radians here, our degrees here. Now I'm going to zoom in just on this first quadrant. Quadrant. All right, so with that, I'm going to throw in the ones that we've already learned, that we already know from our unit circle. And then we're going to put in the new ones in a few seconds after that. So first off, we know 0's here. We know pi over 2's here, which is 90 degrees. Oops, sorry. Pi over 2, 90 degrees. We know that. Now, inside here, this is pi over 6, pi over 4, and pi over 3. We know again this is 30 degrees, 45 degrees, and 60 degrees. Now the other ones that are blank right here, sometimes we'll use them, sometimes we won't. And the reason why I have it on here is because if you look at your textbook, it's in your textbook, so I don't want to confuse anybody with why does Mr. Hall not teach this part, but it's in the textbook. So I'm going to show it to you, but then I'm going to tell you like what you really need to use. All right, so here, this is pi over 12. And this part up here is 5 pi over 12. And we're going by 12s, in other words, here to get next. So, never mind, I'm not going to talk about that part. But each one of these, they're going by 15s. So from 0 to here, it's 15 degrees. From 15 to 30 is 15. 30 to 45 is 15. 45 to 60 is 15. Then 60 plus 15 would be 75. And then 75 plus 15 is 90. So each one of these, this is your first quadrant. Pi over 12, pi over 6, pi over 4, pi over 3, 5 pi over 12, pi over 2. And then 15, 30, 45, 60, 75, and 90. Bam. Okay, now going to the rest of them. I'm going to add on the ones you already know. So 2 pi over 3. Let me move it over some more. So we have 2 pi over 3. We have 3 pi over 4. 5 pi over 6. And then we have pi down here. And with each one of these, we already know this is 125, 135, 120, check, make sure, is that 120? Yes, that is 120. Sorry, 120, not 125. So 135, and then 150. Got thrown off a little bit there. It's not cool. All right. Now, when it comes to the other parts here, you have 7 pi over 12 is this one up here. And on the side down here, this is what? 11 pi over 12. Pull that a little bit. And again, here for this side, you're adding 15 to each one of them. So if you add 15 here, that's 105. 15 is 120. Add 15 is 135. Add 15. Then add 15 again would be 165. And then we have 180. And then it continues on. And so here we have it's 7 pi over 6. We have 5 pi over 4. And then 4 pi over 3. And then 3 pi over 2. Oops, sorry, you can't see it. There we go. My bad. And then putting our values here is 210, 225, 240, and then 270. Okay, and then the other ones adding in is 13 pi over 12. Then we have 17 pi over 12. And again, adding 15 each time. This is 195 degrees. And this down here, if you add 15, it's 255 degrees. Right, and then going around, again, adding what we know, because we already know these unit circle values. If these parts go in here. Okay, and then this part here, we know it's 300, 315, 330. Then adding in these new ones. So 19 pi over 12 and 23 pi over 12. Again, adding 15, that's 285. Adding 15 here, it's 345. 345 right there. All right, and then the last part we already know. This is 2 pi or 360. All right, now with everything else that's here, those are all of our angles. So all of our angles here, pulling out some. So it's nice and pretty, nice and circle-wise. All right, now the other part I'm going to do really quickly is the R's. Now, just for reference sake for right now, I'm going to label these 1, 2, 3, 4, 5, and this would be 6. So this whole circle right here is 1, this circle is 2, this is 3, this is 4, 5, and 6. So the R's are like the first thing that we deal with, the circle, and then the angle is the part around here. Now, as we will notice later on, each one of these circles can be changed to different values. So it could be 2, 4, 6, 8, 10, or it could be 1, 3, 5, 7, 9, or something of that sort. It can be any value that you need to as long as it's in the correct increments going up. So as we move forward, these will change, but as right now for a parent function type function or parent type graph, this is what it's going to look like. All right, so that's it.